I will record and okay, so recording now, presumably in the cloud. Great. Um, Hi everybody, welcome participants in the MetaMask plugin system developer alpha. We're calling it an alpha right now because the APIs are so rough and dirty that we absolutely don't want to suggest for a second that they're stable. That said, there's a lot of good things going on and we're pretty excited to get this in your hands and see what you can build with it. You can see my screen here, Eric?
Yep.
Cool. So joining me here is Eric Marks, a member of the MetaMask team who you might know from his writings and works on our login permission system. The plugin system builds on that system and does some cool stuff. Right away, to get started, you're going to get invited to this plugin beta. This is the MetaMask. It's basically a fork of MetaMask. You're going to want to get familiar building it locally, have Node installed, and then basically yarn install, and then npm start is what I do. When you run npm start, it goes into development mode, it auto reloads, so you can actually change files within MetaMask and edit it. You may not need to edit your MetaMask at all. We've exposed a lot of APIs, so hopefully a lot of your work is just going to be playing with plugins, but we know that a lot of the kinds of changes that this plugin system is going to suggest might and will require big changes to the wallet itself. So if you're really gung-ho, you can even get in there. But for now, basically treat this like this was a really rough version of MetaMask that allows you to write a new kind of dApp. Like for the quickest up and running, I think you just should try working with it first. To work with it, we've got this other repo we've invited you to called plugin. It's actually a command line utility. Eric made it over here. Its usage I've printed on the screen here so you could kind of graze it while I'm talking. Basically, it lets you take a source script and build a plugin bundle, and then it also helps you serve it. Now, the plugins are served on a subdomain today. Like you might just serve it on localhost, which is what I'm going to be doing. And in that case, all of the permissions you're granting to that plugin are constrained to that subdomain. So this is like a single origin, same origin policy in the browser. Eventually, we want to support more decentralized options like ENS and all that. But for right now, for development, we presume that localhost at some port is going to be the recipient of most of these permissions. So I'm going to just show you how to get started. So when you've pulled down our plugin repository, this is, you can see I've got it called plugin starter here. We renamed it. But it has in it, in addition to being able to install it globally, it also contains some examples. And it's got some pretty cool examples. If we go into examples, it's actually just got 3 right now. We've got 3box, which you might recognize as a sort of decentralized identity. Ping pong, which is really the MVP, just showing you how to interact with the plugin and back. And then to kind of really flex a little bit, we made a really bare bones BLS signer. It's a type of cryptography. It's what Dfinity is using in their blockchain. And we kind of demonstrate how you can use this plugin API to do that sort of thing. So to get our feet wet, let's start with the pink. No, I'm going to start with the BLS. I'm not going to waste your time too much. The structure of a plugin is actually the same as a Node script in JavaScript. We've got some important stuff, though, in the package.json. So if we go into the package.json, you're going to see that there's this Web3 wallet key. And it points at some of this stuff. This is part of what the plugin script does, is it points these at the right things. But then you also are able to define requested permissions right here in the package.json, which is following the exact same schema that we use in the login permissions framework. So in this case, we've added a special permission called confirm, because these plugins, they don't run in a normal browser context. They live in a secure ECMAScript context, which has basically no permissions by default. We've got a wiki on the plugin beta thing. And if you're curious about secure ECMAScript, I made a page about it. It'll tell you a little bit about the sandboxing kind of theory behind how this is working. But basically, we're not giving you any permissions by default, except for very explicit ones. Let's go back to the wiki. So on the plugin API, I'll show you exactly what we're exposing. We're exposing only right now fetch, crypto. Oh, we're actually also adding subtle crypto now. I need to add that. And then we've got this global wallet, which is, it is the Ethereum provider, but it's got some special stuff too. So it's got an event listener, so you can listen to wallet things. This is a totally private API, just so you can really integrate during this beta, and then propose the events that you really need to subscribe to. We've got, this is also basically a special event, the on unlock. So this is when you have keys available to you. We also allow plugins to register their own RPC message handlers. This means that the provider that's injected into websites the user visits has the ability to send messages to your plugin and get responses. So you can provide custom APIs. App key is used by basically for anything that involves custom cryptography, or a time that you need a key that you don't ask MetaMask for permission to use. It's documented further below. And then we've got some methods for persisting state and restoring state. So let's just look at the body of this plugin. In this case, we've got, it's just index.js. In fact, this whole plugin I've got in 36 lines of code. Partly because I found a great little BLS library right on NPM, and it successfully compiles into secure ECMAScript. So it means it doesn't have, basically it doesn't use too many clever JavaScript tricks. MScript and things you might have issues with. The MM thing, the MM plugin script will throw errors. It'll try to run it through secure ECMAScript. If it doesn't, it'll warn you. Okay, so
yeah, and I'd just like to chime in with a couple of things there. So I wanted to note that we were joined by Dan Miller, who right now stepped away from his laptop, but who is also a core part of this effort. And as far as the MM plugin script goes, it's under active development as well. And so the best resource for figuring out how to use that is its help command, as well as the README on the Git repo. And so just, and we'll add a change log to that, because we have, its API is undergoing changes as well.
Cool. Thanks. Yeah. So yeah, all of these are kind of rough APIs. We're going to try to make sure that they're always in lockstep with each other, though. So as long as you pull the latest MM plugin with the latest extension branch, then they should be compatible. So most of it is we've got this BLS function. We've imported this very nicely formatted errors module, also anti-error. And then basically most of the module is a single listener. It's a register RPC message handler. And what we get is we get this request object. This is the exact request object that would get passed, via the provider. And you can detect its method, and you also get access to its params. So it's just it's unmolested. And I'll show you in a minute how adapt sends a request to a plugin. But in this case, we made a switch statement for methods that we want to support within our plugin. So I want to let a plugin get our public key. This is our public BLS key. And then we want it to sign a message. And I want it to actually prompt the user for confirmation. Now, we don't have like a rich MetaMask-like confirmation right now, but what we did include is, like I said, we added a confirm method. It's a restricted method, but you can ask for permission from the user to use it. And then you can basically send that confirmation. Again, the way we got that permission was in the package JSON. Under requested permissions, we got that confirmed permission. So that means when it's getting installed, the user is going to get prompted for that, and just as part of the plugin's installation, and then you'll have free access to calling this method in this way. So we're saying, well, let's send the confirm method with the message, which in this case is, do you want to sign that data with your public key? And then we're awaiting the response and returning the response result. You have to unwrap it, just like when you're using the Ethereum provider directly. And we take that Boolean back. If they didn't approve it, we're throwing an unauthorized error per the JSON RPC spec. And then then if otherwise, we're gonna get the private key from the wallet. And here you can see this is one of our special APIs that we're exposing right now. This may eventually be available to all dApps, but we're using this beta branch as an opportunity to show off some proposals that have been in the ecosystem that could enhance your ability. So there's really no reason. So what we're doing is when you call this method, the wallet is basically taking its current account, its private key, and it's hashing it with your domain string to generate a new private key. And this means it basically is able to give your domain a private key that it's just trusting you with, and it's able to regenerate and restore. So that means if this user's MetaMask gets wiped and then they reinstall your plugin, you're actually going to have the same app key. And so because MetaMask is making its users back up a seed phrase, which is a big pain in the butt, but it means that now every plugin benefits from their users having access to a secret. So we can support basically any kind of cryptography. This private key it's an Ethereum private key, but you can use it as a seed for whatever cryptography you want. And like I said before, we're exposing the browser crypto and subtle crypto libraries directly into this context. So you can do all sorts of fun operations on it. And then we return the signature. So how would we use that in a dApp? Well, I'm glad you asked. Let me pull up the index.html from this example. In here, it's a pretty simple dApp. We've got a couple buttons. We got to connect, get public key, sign message. Actually, maybe I should just show it to you. Got it right here. So we've got a connect. Connect is going to initiate a connection. Let's see exactly what it's doing. It's going to connect. Okay, so it's going to send wallet request permissions with the plugin origin as the permission name. Now, plugin origin, what's that? Oh, well, it's this special kind of method where it's basically a wildcard permission. So if you say wallet plugin and then the name of an origin, if you request that permission, MetaMask is going to check this origin to see if it's hosting a package JSON. The origin actually includes the package JSON. So you have to point at the package, which also points at the other scripts. So then MetaMask is gonna load that all up from this. And if the user consents to installing that, they're going to install the script from here in a secure ECMAScript sandbox. And then it's going to forward subsequent requests to this string as messages, and that's what's triggering these register RPC message handler calls. So if the user approves this permissions request, then we're going to find that we can now on subsequent calls to it, if we send messages to the plugin origin, this is a fancy provider method where you say the method name for the first argument. That method is actually not supported on the wallet provider in here. Sorry about that. So we're sending to that plugin origin, and then in here, this is just a full request object. So it can have a method, it can have params here in the case of the sign message, and we're just interacting it like it was MetaMask. A couple gotchas is this initial one is the permission to install it. Right now, we aren't actually installing it until you send your first message to it, which makes for a slightly weird experience, but just bear with us. So let's feel that out. I click connect. This is going to request the initial permissions. So we are, I think it's going a little slow right now because I've been running a lot of stuff, but here we go. So right now, this is how we're wording it. We're going to tighten this up as much as we can, but it's to connect to this plugin and install it if it's not available yet. So this would be the same prompt where a dApp would ask for your account. It would ask you to log in. I can actually select an account here. So this is effectively the account selector. You haven't seen that feature before because it's not in production MetaMask yet, but being able to select your account when you log in, and then any number of permissions can be associated at login time. And then we're going to submit. I don't have a really rich UI here, but rest assured it's connected. And now when I make my first call to the plugin, it's going to install. Oh, there's a problem. Oh no, how embarrassing. Cannot destructure source code of undefined or null, huh? Does that look familiar to you, Eric? Maybe we should get familiar with...
yeah, I think that's...
I know what it is. Oh, I'm sorry. I totally... Sorry, I'm not running any services in here. I have to be hosting that localhost thing. Sorry, you're probably going to beat me to that, but... Okay, so let's just do that now. Here I am in my BLS signer example, and basically all I have to do is mm plugin serve, the current directory, and then the port. So 80, what port did I say I had to be? 8083 is this one. 8083. Okay. So that's what's going to let me, yeah, had I reloaded, I would have noticed that that was broken. Okay, so I should still be connected because MetaMask hasn't reloaded. So now let's call get public key, okay? And it did initiate a MetaMask prompt. This is because we postponed, it's lazily installing. So now here's the, we're gonna obviously clean this up, but here is the plugin asking for its permissions. So it wants permission to run, we'll probably say a script, and it'll be able to do the following. And in this case, remember we asked for that prompt permission. It's saying it wants to display confirmations for user action. So that's how we're describing it right now. One of the important things with the permission system is that we need good, coherent human descriptions for each permission. That's what makes it informed consent. In this case, I am all for it because I just read the source code. And here's my public key. Sorry, I didn't hexify it, but here it is. This is my public BLS key for my first account. So I could feed this into you know, whatever thing I wanted. You know, presumably my DApp would actually interact with it. Now I can also sign messages. So I can say hello. I can say sign messages. Remember, this is going to invoke a prompt. And here you say, do you want to BLS sign hello? And you can see I actually even added this little header. So you actually don't get a choice. So we clarify what domain or what extension is asking for a given thing. This will probably become a rich thing. We'll probably come up with a pop-up API. Like if you want to initiate a user interaction, we'll have a way where MetaMask shows a prompt so a user has a sense of where it's coming from and will indicate who's asking for that permission. So if we want to sign hello with our good old 138 key, we say okay, and here it is back. So 143 17 157. And just to make sure, I want to make sure it's working right. Let's make sure 143 isn't the same because that's the I love you message. Okay, so let's say okay, and 149. Okay, so I'm getting a different result. So yeah, I seem to be running a BLS cryptography right here in MetaMask. Now I could go to a different domain that asks for permission to talk to the same plugin now, and it could ask for signatures from these same keys. So this is it's like a type of DApp that moves around with my wallet. And so one of the original criticisms of DApp keys was, well, if you're binding them to a domain, how do you move keys between sites? I think plugins are basically the answer to that. The plugin is the portion of your wallet that's constrained to a domain, but is able to provide services to external things. Now you might say it's really annoying that right now this is all just RPCs. Yeah, the RPC is awful. We're actually working right now on a cool little module that should allow much more versatile APIs to be provided. My hope is that you can basically provide an object with some promise returning functions on it, and we can basically inject that right into the browsed site. But that's all coming down the road. We wanted to get this in your hands as quickly as possible, and for us that meant having the bare minimums of developer toolings and documentations together. Yeah, this wiki I think will be your friend. We encourage you to help enhance it as well. You know, there's a lot of missing things here. We have not documented the exact events. Oh, also on the provider, we tacked on a whole bunch of extra methods. So here we are in the plugin repo. If I go to app scripts controllers plugins, I think plugins is where I put it. Right? I'm looking for all the extra restricted methods. So in here, this is the plugins controller. This is where you'll see us using SES and doing all that cool stuff. And it's also where you can inject extra things. So root realm, for example, here's where we're taking the source code of a plugin and we're evaluating it. This is a secure eval that does not provide ambient authority except for what we inject. So here are the globals you currently have access to. You get console, bigint. We're making a mocked window that just has crypto settle, crypto and fetch, and we're putting them globally as well. If you find yourself, you just need to hack some stuff together, just tack some stuff in here. SES will complain about some stuff, but that is the quickest, like if you need an MVP and you're not trying to submit an EIP about it, here's how you hack MetaMask real quick to get the result you want. But also there's all these other, the provider we're injecting, the Ethereum provider, right, from...
All those methods are listed in the permissions controller folder in the restricted methods file.
Oh, it's in the restricted method file? Okay. Restricted controller, permissions, restricted methods. Okay, cool. So this is where we define all of the things that are part of the Web3 wallet permission. So Ethereum magicians, we've got our Web3 wallets proposal and Web3 wallet permissions. Yeah, there we go. Web3 login permissions. And we've got everything that uses this wallet request permissions API is exposed via this basic type of object. So this is how we define those things. So actually here is the wallet plugin. Here's how we define that special namespace using a module we described. You actually could use it if you want to make your own special confined namespaces for restricting your methods. It is using this nifty little module we made called JSON Art. It's a very long name, RPC capabilities middleware. Sorry, naming is it's not my forte, or rather, you know, it's hard to name some things. But yeah, basically, you make one of these. You make a JSON RPC engine. You initialize one of these guys with some restricted methods, and now it will expose. Oh, and you also define how you want to get approval. And then yeah, it'll just basically put a wall in front of all of those methods, make sure user always it accepts them. Anyways, that's getting advanced. The other methods that you have though is all these things in plugin restricted methods. These are not currently exposed to dApps, but these are all functions that you can call on the provider within your plugin, and we're just including these. Just you know, a special gift from us to you. This is basically because we haven't gone through what are all the APIs, what are all the safe things to provide to plugins. So instead, we literally went down all the APIs that we use in our user interface, and we just exposed them all. So if you want to know when there's a new transaction, oh, we do have a fetch. Do we have a fetch? I'm a little surprised. Look, we're injecting fetch.
No. That's the fetch that they can request.
Oh, cool. Hey, here's Dan Miller.
Yeah. That's the fetch that can be requested. Also, the first one there on NewTX has been removed.
Okay, cool. Yeah, so I could almost delete that. Okay, so yeah, we've got a way to request unlock box. We've got a 3-box one. Oh yeah, because you've added 3-box for. We're adding that for optional backups. Cool. Yeah, I think this is where. Oh yeah, here's where the real internal API is. It's this MetaMask controller get API. So. For example, you might notice that MetaMask sometimes detects the names of functions in the transaction thing. If you want to be a registry plugin, you can just tell MetaMask what to recognize or how to describe a function to the user. You can add accounts, key rings. You can list new tokens in their wallet. You can forward them to initiate buying if you can't force them. But yeah, all sorts of fun stuff. Yeah, you can check if nonces are taken by the user. You can nickname their accounts. Yeah, so anyways, this is like total control over the internal MetaMask state, but you have to ask for each one. The string following each one of these is the thing the user would be prompted with. So even though this is kind of very haphazardly assembled for the purposes of a beta, it still has a descriptive string. So I think there's kind of a neat amount of security that you're getting even in this beta. So it should give you a sense of realism about what am I really asking for a user. And you know, and that's really great that we're able to confine it so much because, for example, as a browser extension, we have really coarse APIs. So that's why when you install MetaMask, it says ability to edit and read the data on every site you visit. And that's like a really coarse and dangerous API. Well, cool thing when you're installing a MetaMask plugin, you can give it much smaller surface. A MetaMask plugin doesn't have the ability to edit a site. Maybe we could define that permission. You know, maybe we could make a plugin that adds a tip button to Twitter or whatever. But by default, nothing can do anything, and we're aiming for very granular permissions. So one of the things we'd like from all the participants in the developer beta is find the meaningful permissions that you would want for your plugin, and make the case for them. And hopefully we come up with some really cool ones. You know, be creative. Let's make an interesting platform. But in particular, we're not looking for permissions that are just tailored to individual use cases. We're looking for permissions that can really foster innovation and creativity throughout the ecosystem. This is effectively a way of us unlocking the creativity of the ecosystem. We don't want to be gatekeepers. we don't want to tell people which features are getting through to users. We want to just really kind of set the web free. That would be our wish. Cool. So I think that's basically everything I had to say. We got this wiki. What are you guys thinking, Dan or Eric? Did I cover the things you thought were important?
Yeah. I think we're good. I mean, I think it may be worth mentioning that we are exposing all of our internal APIs by default at the moment, but over time we may determine that some of them aren't safe to expose, and we may retract them at a later time or restrict them in some way to make them safe for plugins to use.
Yeah, I think it would even be safe to say by default, we're not planning to ship any of these to production unless they are like obviously actually useful. There were only a couple that we didn't expose because they were like obviously obnoxious, like telling somebody to skip the seed phrase or just like internal flow functions.
And also notably, functions that would allow approval of transactions or message signatures. Right.
That's the most important kernel that remains in our hands, right? Yeah, good point. So yeah, we're trying to open it all up, let the user choose what they want to do with their wallet. But the one thing we won't let them choose is to give up their choice itself. I don't know. We might let the user delegate. No, I mean they effectively are. And eventually we might add, for example, a send transaction permission. That's very contentious issues on Web3 wallet on the Ethereum Magicians thread. But this is a great place to start discussing things like that. What would it take to make that secure and trustworthy? Would it be granting that permission just to a static site? Actually, I have the thought it might be more secure to grant a permission to a dynamic site with like a really rigid update policy, because there can be a bug or a vulnerability in a static site. Like if we delegated transaction approval to an IPFS hash, there could be an error that lets somebody permanently approve transactions for you. I think updatability is actually a big security feature. Anyways, we can have that whole debate later. Sorry, I'm rambling now.
That's okay. I was just going to make two comments. One, to follow up on Eric's point that, yeah, it's possible that any of these APIs, these sort of internal MetaMask APIs that we're exposing now for the plug alpha phase, any of them may be removed. However, if someone was to prove that something very cool and powerful could be done with them, then that would strengthen the case for including them. The second point I think is important to make at this time is that the way the plugin system works and sort of the like the set of APIs and the way the build tool works, everything that Dan walked through in this video, that is subject to change as people begin to experiment with the system. And so I think the wiki will be an important sort of resource, and I think we should try to treat it as a source of truth for like keep it very up to date with the API and the way the system's operating. And so it'll be important to sort of follow changes there as they're made.
Yeah, absolutely. So yeah, please do chip in if you find things that we haven't documented adequately, but also check here if something isn't working right. We will at the very least keep it in lockstep with changes we make. I think that's a fair commitment to make.
Yeah.
Cool. I see no reason why we should record any longer and postpone sending out this email. I think people have been waiting a long time. Cool. Anything else?
No, sounds good.
Right on. Let's
Sweet.
do it.
Cool. Well, thanks so much. It's been a long week, guys, but I'm so excited to play with this myself and see what others make.
Yeah.
Cool.
One thought I had though is, yeah, I know if we can find some secure ways to expose, like send confirmations and message signature confirmations, if we find like some sort of security model that works for those, I think that would be very cool.
Right.
That'll,
yeah. For right now, we've got the confirm function, which is I mean, I think it would be secure. It's just really ugly, right?
Oh, but it's not. We have the confirm function, but you can't confirm pending transactions, for instance, in MetaMask, right? Or unapproved transactions within MetaMask.
A mechanism for approving other. Right. Yeah. So, well, one way of looking at it though is that so just the same way a plugin gets to define all of its own internal security logic, it could accept messages from one domain and allow it to perform those kinds of operations. The security model is totally in the hands of the plugin developers. The same way we could just firmly, right? And I guess maybe I'm moving the goalpost. Same way we could expose the ability to just delegate approval itself. Like maybe somebody makes a better confirmation window, for example, right? Like better transaction approval.
Right. So that's what I'm thinking is that you say the ability for someone to make a better confirmation window, or the ability for someone to make a confirmation window that was customized to their UI, right? Their UX.
Right.
To do that, we would have to allow the plugin to be able to call our internal transaction approval methods, right?
Right. Yeah. And we might just expose a method that's like permission to render the confirmation on this domain or something, or transactions through this contract. Like, because for example, you might trust the game to render its own transactions more than you trust anyone else.
Right. Yes, that is a good security model. That you could grant permission to approve them for a given domain or contract. I think that would be very good.
Yeah, and it's fun because this is a really crappy BLS signer, but if you start composing it with the ability to delegate its own rendering of a prompt, given different contexts. So if it had some internal logic, it could switch based off of the structure of the data to sign, and then then delegate the rendering of those different confirmations to other things. Sorry guys, this is what a MetaMask geek out looks like. We're constantly thinking about what it means to coherently sign otherwise unreadable cryptographic bytes.
We're still recording.
Oh yeah. Oh, we don't have to keep any of this. Yeah, but it is interesting to think, and I like to think some people let it run long, and I mean, I think a lot of dApps would like to render their own confirmations. So that may be a really contentious kind of change to make to MetaMask, but somebody presented a secure model and a strong case for how we could do it well. I think that putting that decision strongly in the user's hands is the way that I think we would accept the frame. What I'm not as interested in is we'll trust our TCR or buy our token. That's going to choose how to render your thing. Of course, we could sell the token. Of course, we could sell our trustworthiness on the open market for how to render transactions, but that doesn't seem like the best thing for users. So we will merge in what we trust, and then we'll let the users approve what they trust. That's kind of my current thinking about this.
Yeah, and as far as the send transaction permission goes, I have ideas for the atomic rights and the atomic state updates, and I think we'll see in the due course of time.
I think it's just going to be a race between can you devise the secure way of granting transaction sending permission within the wallet faster than we can just delegate that to contract accounts via plugins. So I think that's the race. Yeah.
True. I mean, if we go over to complete account contract or contract account model, then it might not be necessary to do it. Although I do see a distinction between like a contract account giving a dApp a permission to spend a certain amount of ETH on your behalf, and you granting like a spending limit for while you're browsing a certain dApp for a period of time, of setting a spending limit for that, which you would probably need to do like through your wallet.
Those both sound really similar to me. There's like one's a spending limit and the other's a spending limit. How are they different? Can you clarify?
Because I think, well, they're different. Well, they're different in the sense of like, because if you have, well, I guess I'm not clear enough on how contract accounts work in order to understand if they can fully, like if they can operate on sort of a one-to-one basis. But say I have a contract account of some kind. It has a spending limit permission that it gives to some address. That address can sort of make transactions and spend things without me directly interacting with it, like on chain. Potentially, like again, this is where like how contract accounts actually works comes into play, but potentially without me interacting with the dApp directly or like being on a page and like viewing it and taking other actions like within a dApp. Whereas like if I'm browsing and there are a bunch of like micro transactions happening and and like just small stuff while I'm like on like Gods Unchained or whatever in the browser, then sort of a local like wallet spending limit might make sense as opposed to an on-chain one.
Okay. So I think I see the distinction. And yeah, I think it depends. It's not just about how do contract accounts work, it's how do they become architected. Because like I think today, most of them still depend on-chain transactions to adjust permissions. So like the token allowance method is like an on-chain transaction, but it's my strong opinion that there's no reason an allowance needs to be an on-chain transaction at all. So I'm really looking forward to somebody making a contract account where permissions expansion is an off-chain message, and only at the time that permission is redeemed or retracted is there an on-chain transaction. So yeah, that's that leads right into my good old object capabilities thing. And I encourage anyone, if we ship this video this late into it, I encourage anyone to go into it because that's exactly what it's about. Talking about all the different things that follow that model. And actually, meta transaction is a good example of kind of what you're saying, right? It's an off-chain message. Somebody else submits it to redeem some permission. In this case, a fee. The same for OS probably relays.
Yeah, and I think the demo we did, like the demo part of this video, was really good. I thought you were laying it out super clearly.
Sweet.
So I think if you, with some editing magic, I think it's definitely shippable. We could as a send off record sort of like a enjoy the
thing. Like,
enjoy the thing, guys.
or singing. Yeah, we each get our instruments or whatever and do like a song. Cool. All right. Well, I'm gonna hit the recording there.
All right. Awesome.
All right. Thanks, everybody.